Okay, we're going to be finding the derivative this time using the definition. And I remember when I was first learning this stuff, I hated it. And I've kind of picked a semi-easy one to do. And keep this in mind that there is a lot easier way of finding the derivative. But we're given f of x, and we want to find f prime of x. So remember what our definition is up here. And this is what we're going to want to find, f prime of x. And so we're going to be using this. Right? Let's first take a look at the graph so you get an idea of what's going on. Okay, so here's the graph for function x squared over 2, and we're going to be finding the slope. The idea is we want to find the slope of the tangent line, this red line right here, or whatever color you're seeing it as. We want to find the slope of this. So we're going to need to come up with a function. So when we plug 2 into this function, it's going to give us the slope of this line. And so this is what we're going to use. So f of x plus delta x means we're going to take x plus delta x and we're going to plug it into the x in the function. So here's our x in the function, and we're going to substitute that x. We're going to move it out and plug all this stuff in place of it. Boy, I remember learning this for the first time. That shit was confusing. Okay, so take this, set it aside, keep the square there. Pretend this is all one solid object. This is all one solid piece right here. Okay? This whole solid piece now gets placed right in here. Alright. And then, so it's squared over 2. Right, so this is our f of x plus delta x minus our f of x, and our f of x, remember, is just the x squared over 2. And then we are rewriting the delta x here. Now what we're going to want to do here is simplify this down as much as we can. We want to simplify this down. So we're going to have to square this. So this is, you can see it like this. It's x times x is x squared, right? X times delta x times x, so that makes that 2 of them, and then delta x squared minus, and then our function here. All right. Now what we're going to want to do here, we got common denominator, so we're just going to add the tops up here. So we have x squared plus 2x delta x plus delta x squared minus x squared, and it's all over 2. You can do that since we have common denominator. And then what we're going to do is cancel the x squareds out because we have a positive one and a negative one. And let's see, what do I do here? Actually, I take this 2 and drop it down. Alright, drop it down. Seems like I just rewrite this twice. It's totally unnecessary. I don't know why I did that. Or 3 times. Okay, so the numerator, remember the x's cancel, x squared's canceled out, so this is what we're left with. Now, I have a delta x, 2 delta x's here, 1 delta x there, so we can cancel a delta x out. And this is what we're left with. And then what we're going to do is go ahead and do the direct substitution. Plugging 0 in for delta x, and you get 2x plus 0 over 2. And I don't know why I rewrote that over here. I must have been asleep that day, or that night, or whenever I did this. But anyway, it's whatever. And so after simplifying this down, you see 2 goes into 2x, so we're just left with an x. So there it is. F prime of x is equal to x. Wow, all that work just to get x. Now, we want to find the slope when x is 2. So we just take 2, plug it into the function, and we get 2 out. Now, the interesting thing about this right here is we can plug any number on the x-axis right into that, and whatever that number is, we're going to get out. So if I plug 3 in, we get 3 out. That's kind of amazing. But let's go back to the graph. So here's 2, we plug it in, and the slope of this line right here is 2. Alright, so if I was to plug negative 2 in, we would get the slope of the tangent line be negative 2.